everybody, welcome to tonight's stream. I'm just gonna go through, as on the title here, just gonna go through some more of our question pool for the extra class. Studying for my upgrade, figured I might as well share it with everybody and maybe we can all take part. Plan of attack is probably going through another 10 to 15 questions or so in the section we're currently in, which I believe where we left off was we had started into Skywaves and Contesting section. So we'll continue on there, going through some more of the questions. Get anybody in the chat, feedback and what have you. Try to entertain some of that as well. So grab a beverage of choice, pull up a chair, and come on in and join me, and we'll kind of get set up here and get right into it. So let me get us to our there we go, our Gordon West 20 to 24 extra class prep book. So we'll kind of get here to make sure we got a good can see the everything's nice and clear. We'll try to get this all set here. Gotta get so we can see everything as we're going along. I thought I had this all positioned, but maybe I gotta do a little more position in here. Bear with me, folks. There we go. Sorry, I apologize. I thought I had it all positioned and everything showing good, but apparently it was not. So I apologize for that. Alright, I wanted everybody to be able to kind of read along as we're doing here. Okay. I'll just have to make sure we stay in the camera shot as we're going. So, our first question here. What is indicated by a rising A or K index? Is it A, increasing disruption of the geomagnetic field? B, decreasing disruption of the geomagnetic field? C, higher levels of solar UV radiation? Or an increase in the critical frequency? I know this is all about your solar and everything, so I'm going to go with C. But I think A or K might deal with something with the geomagnetic as well, but I could be mistaken. It's been a little bit since I've looked at any of this information, but I'm going to go with C for myself right now. If anybody's got any other opinions, please post that. But A and K basically indices are provided by data from terrestrial magnetometers. Excuse me. They are sensitive indicators of solar activity, but need to be interpreted carefully to be truly useful. Learn to read the A and K indices as they rise. They are telling you that there is an increase in disruption of the geomagnetic field. So A. So there again, I was incorrect. See, that's why we do this. Study now, so we do well. And if you're not looking at this stuff all the time, you know, it definitely makes a difference here. I've been preoccupied with others, so I haven't really been looking at anything. Well, I'm just drinking a soda for tonight. You know, I got a little root beer just for for tonight. So, all right, next question. Which of the following signal paths is most likely to experience high levels of absorption when the A index or K index is elevated? Is it A, transequatorial, B, polar, C, sporadic E, or D, NVIS? I'm thinking you're sporadic E, but it may be the. Since the Earth's magnetic field lines are concentrated near the magnetic poles, not geographic poles, magnetic disruptions are also mostly concentrated in these regions. The ionosphere near the polar regions is magnetized plasma, which has some interesting properties. Not only is the absorptive to radio waves, but it is directionally absorptive. Yeah. Sorry, boy. Don't let anybody tell you there's no such thing as one-way propagation. It is the norm in polar regions. So, polar regions is the correct answer. Well, I'm off to a bang-up start here tonight, folks. And again, and like I've said in the past, in these anything in blue is of importance to remember for studying and for your test. That's kind of like key information. Next question: what does the value of BZ or B sub Z represent? Geometric field stability, critical frequency for vertical transmissions, direction and strength of the interplanetary magnetic field, or D, duration of long delayed echoes? Well, I'm not even going to take a guess at that one because I don't think I've ever come across that particularly for myself. So, the Sun and Earth have interplanetary magnetic field which contributes to the character of the Earth's ionosphere. Just like a familiar bar magnet, the magnets embedded in the Sun and Earth have poles that either attract or repel depending on their orientation. The greatest effect occurs when the Sun's north pole magnetically connects with the Earth's south pole. The magnetic field orientation is defined relative to the interplanetary, which is the plane of the orbit of the Earth around the Sun. The z-axis of B, the magnetic field, is north-south axis of the interplanetary field, perpendicular to the ecliptic, which is roughly the same direction as the Earth's north-south axis. The X and Y axes have minimal effect on the Sun's Earth interactions and are generally ignored. C is the correct answer for this one. So we'll mark that. Direction and strength of the interplanetary magnetic field. Last question for this page. What orientation of B sub Z increases the likelihood that incoming particles from the Sun will cause disturbed conditions? Good evening, Rosa. Is it A, southward, B, northward, C, eastward, or D, westward? So what orientation of B sub Z increases the likelihood that incoming particles from the Sun will cause disturbed conditions? Well, that's a guess at that one. So it is standard practice to designate the type of field with subscript denoting the axis. In this case, B designates the magnetic field, the interplanetary magnetic field, and Z designates a z-axis, or up-down orientation relative to the ecliptic, the plane of the Earth's orbit around the Sun, just as two bar magnets interact most strongly when the opposite poles are near each other. The Earth has the greatest interaction with the magnetic field when that field is orientated north to south or southward. So now the real interesting part is that unlike the Earth's magnetic field, which is fairly fixed, the interplanetary solar field is carried by solar wind, which means that it's variable as the weather. Interplanetary magnetism can range from almost nothing to huge and can change very suddenly. So A, southward, is the correct answer for this question. I'm starting to realize as we're going through some of these skywaves and contesting is a very tricky section. Get this set to the next page here. Make sure it's in view. Thank you. I'm a North Country bumpkin, so some of this pronunciation I can always improve. So which of the following descriptors indicates the greatest solar flare intensity? Is it class A, class B, class M, or class X? Hopefully it looks like it's a little fuzzy but on my screen, but hopefully it's clear. That's about as clear as I'm going to be able to get it right now. Okay, think of X class as being extreme. The X solar flares are extremely disruptive as they emit large quantities of charged particles and as you might suspect, a lot of X-rays, which can certainly create a lot of ionization, but not the type that you want. They penetrate the atmosphere so that they excite the absorptive D layer far beyond what is normal. The nice thing is solar flares don't last forever. I guess they recommend a website to kind of see on some of this. It's spaceweatherwoman.com to learn more about space weather coming from the sun. So the answer is D, class X, which they kind of alluded to a little earlier on. So, all right, next question here. Well, a little good to know fact. I won't kind of hit all of this here, but WWV and WWVH space weather broadcast, the National Oceanic and Atmospheric Administration, NOAA, which uses the WWV and WWVH to broadcast geophysical alert messages that provide information about solar terrestrial conditions. So it just kind of talks about, so a little blue tip down here. This is going to be important probably for our test is when we get the news of a flare on the sun like this, expect some unsettled band conditions about 40 hours later. So whenever we get kind of warnings on some solar and sun flares, about 40 hours later, we're probably going to have some interference and stuff going on the bands. So it's a good thing to keep in mind, a little food for thought. All right. So our next question here, moving right along. How does the intensity of an X3 flare compare to that of an X2 flare? 10% greater, 50% greater, twice as great, 4 times as great. Any X-class flare is big enough to cause serious disruption of terrestrial radio communications. The X flares are categorized by factor of X1. An X2 flare is twice as powerful as an X1 flare, while an X3 flare is 3 times as powerful as X1 flare. So by simple arithmetic tells us that an X3 is 50% greater than X2. So B, 50%. That's another one I don't think I've ever seen before. So it's skywaves and contesting, very interesting. It looks like it's going to be a tricky part of the exam. Our next question here. What does the space weather term G5 mean? An extreme geomagnetic storm, very low solar activity, moderate solar wind, or waning sunspot numbers. I don't know if I'm going to take a guess at this one either. Might be the storm, geomagnetic storm, but okay. Geomagnetic storms are a result of solar storms that can be delayed considerably from the time solar storms are observed. After all, Sun is 93 million miles away, and the ionosphere is just a few hundred miles at the farthest. So, A, geomagnetic storm is what the G5. Well, I appreciate the comment there, Rosa. Thank you for letting me know that. If you got anything you want to throw in there or take a guess at a question, go ahead and throw an answer up, and we'll kind of banter back and forth that way. This one just looks like it's some more little food for thought, talking about some storing levels in the G scale, your S scale, and R scale. K index. So let me throw this in here to cover that page and move on to the next question here. Okay. Yep. Okay. What does the 304A solar parameter measure? Is it A, the ratio of X-ray flux to radio flux correlated to sunspot number? Is it B, UV emissions at 304 angstroms correlated to the solar flux index? The solar wind velocity at 304 degrees from the solar equator correlated to solar activity? Or D, the solar emission at 304 gigahertz correlated to X-ray flare levels? Boy. Okay, let's just go right on here. Ultraviolet emissions are good indications of sunspot activity. UV is the primary ingredient necessary for the normal ionosphere to form. The 304A solar parameter measures UV emissions at 304 angstroms. So that's obviously... Ultraviolet activity encompasses a large chunk of the electromagnetic spectrum and can be seen here at the columbia.edu website that's on here. It's www.columbia.edu / I don't know, the little @ symbol, about symbol there. VJD1 / electromag _spectrum.htm. Because of its wide range of wavelengths, ultraviolet is usually subdivided in 2 or more regions. B is the correct answer for this question. So what does 304A solar parameter measure? That's the UV emissions at 304 angstroms correlated to the solar flux index. Well, that's what I'm doing with that. I've got 4 other parts previously on this that I've done the same thing, about 10 to 15 questions at a time as I'm studying for the extra. So that's kind of all I'm doing, just kind of sharing it as I'm going so everybody can study along. But this is part 5 of the series so far, and this is only the second session of second part of the questions. This is the new question pool too, so. Next question. At what time of day can sporadic propagation occur? Only around sunset? Only around sunset and sunrise? Only in hours of darkness, or any time? I think in sunset and sunrise, because we're at the height of day, I thought, but maybe it's any time. While sporadic appears to be seasonal phenomenon, it doesn't seem to care much about the time of day, so I'm going to say it's probably any time. This further adds to the mystery and enticement of the mode, which this means is if you want to work sporadic just plain help to be on the air a lot, since it can happen any time. In all the sporadic log notes, including largest sunspot event in 58, in basically, I guess there was a big sunspot event in 1958. Gordo says he has never encountered any skip on VHF bands from 10 p.m. to 6 a.m. in the dead of night. So the correct answer for that is D, anytime. Let's see here. Next question. Let's just keep it moving. I've been going about 25 minutes here. I've been trying to keep them not super long, but we'll do probably between 5 to 8 more questions here. These next 2 pages will finish up probably for tonight. Next question here. At what time of year is sporadic propagation most likely to occur? Around the solstices, especially the summer solstice. B, around the solstices, especially the winter solstice. C, around the equinoxes, especially spring equinox. Or around the equinoxes, especially fall. Oh, sporadic propagation. I'm going to think that's probably the height of summertime. So I'm thinking maybe the summer solstice, but I'm probably wrong. Sporadic E is this, as the name suggests, sporadic. It can actually occur at any time of the year and is often at sunrise when it does. However, it is most likely to occur during the dead of winter or the dead of summer. The reasons for this are not yet fully understood, but the phenomenon is well documented. A is the correct answer. So, figure around your solstices is most likely going to be the time that happens. Higher probability at the summer solstice. So I guessed at that one correct. And then it is another website to kind of go into sporadic sightings, and it's www.uksmg.org/content/sporadic or sporad.htm. So I don't know if that website shows up very clear on there or not. A little bit of a diagram here showing your F1 layer, F2 layers. You know, you got your F1 and your F2 above with the sun, your E layer in between, and then your D layer closest to the Earth for your ionospheres. So your F1 and F2 become F layer at night. So your F1 and F2 basically at nighttime combine, as we've all kind of learned for our other exams, but that's kind of where that leads. So we'll do all the questions on this page and see where we're at for there. Next question here. Kind of move it into view a little bit more. When a meteor strikes the Earth's atmosphere, a cylindrical region of free electrons is formed at what layer of the ionosphere? Is it A, the E layer, B, the F1 layer, C, the F2 layer, or D, the D layer? When a meteor strikes Earth's atmosphere, I'm thinking because it's going to burn everything up initially, it's probably going to be your F2 layer, but no, I was wrong. The E layer. It is within the E layer of the ionosphere that the 6 and 2 meter excitement, like sporadic E and meteor scatter contacts, take place. Answer is A, the E layer. So I was wrong on that one, but that's why I'm doing this. All right, next question. Which of the following frequency ranges is most suited for meteor scatter communications? Is it A, 1.8 to 1.9 megahertz, B, 10 megahertz to 14 megahertz, C, 28 to 148 megahertz, or 220 to 450 megahertz? I'm thinking your higher end frequencies in the HF band, so I'm going to say 10 to 14, but I could be mistaken. During the recent meteor shower, Gordo was able to maintain 30-second meteor scatter QSOs on the 10-meter band, 10-second QSOs on the 6-meter band, and 3-second QSOs on the 2-meter band. So it looks like it's going to be C. The higher you go in the frequency, the shorter the contact time. 28 to 148 megahertz are the best areas to hear effects of this meteor scatter. So, right there, 28 to 148. Answer is C. Your 28 megahertz to 148 gives you your best frequency ranges that are most suited for meteor scatter communications. And it gives a website for that. And this is making meteor contacts is a great way to work CW during a 3-second burn. Okay, Our next question. Which of the following digital mode is designed for meteor scatter communications? A. Whisper. B. MSK 144. C. Hellscriber. Or D. APRS? Boy. I've heard this talked about a bunch of times too, and I'm just not sure. I'm leaning to Whisper or MSK 144, but I'm not. I can't determine right now. If you are into computers, ham radio digital signaling is just one thing for you. There are many software programs that work with your computer sound card, and there's excellent add-on radio signal controllers that let you more sophisticated transceivers both transmit and receive ham radio digital calls. MSK 144 is the fastest and most common digital mode for meteor scatter contacts with strong error correction, increased sensitivity over earlier modes, and can lead to an exciting catch of other ham bouncing signals off meteors. So, and I've kind of tinkered around with MSK 144 on FL Digi program with one of our weekly nets in the area here that we pass digital messages back and forth, just practicing and playing around. Perseids in August, Germides in December, and Orionids in October are favorite ham radio meteor shower events. What are we looking at here? I'm going to do this next page here, and then we can close out for the night. All right. Let me make sure we're in frame, and I appreciate you joining me tonight, Rosa, and it looks like I got a couple viewers, so that's good. I've done a few of these. I haven't had too many live views, and of course one of them is because my entire system crashed on me 2 minutes before going live, so that was a good way to start that one. Which of the following is a good technique for making meteor scatter contacts? A. 15-second time transmission sequences with stations alternating based on locations, kind of like what WSJTX does. Use of special digital modes. C. Short transmissions with rapidly repeating call signs and signal reports. Or D. All of these choices are correct. I would say probably any of those would work good, since they have to be your shorter signal spans. Any of those would be a good way to go with, but so I'm going to say all of them. There are several different ways of conducting meteor scatter contacts. If you and your friend 500 miles away want to set a meteor scatter schedule, you first make sure your clocks are perfectly in sync with WWV at 10,000 kilohertz. Agreed on who takes the first and third 15-second calls, and then each listens for the other's 15-second transmission. Transmitting west to east takes the first and third 15-second period. Another way for random meteor scatter contacts is high-speed CW. Digital modes are rapidly giving your call sign a few seconds. Listen to Gordo's audio CD course to hear exciting meteor scatter contacts. The answer is D. Any of those choices. So you basically come up with your plan and go from there. And the last question for tonight that we'll hit up. What is the cause of aerial activity? Or auroral activity. There we go. A. The interaction in the F2 layer between the solar wind and the Van Allen belt. B. The extreme low pressure area in polar regions. C. The interaction with the E layer or charged particles from the sun and the Earth's magnetic field. Or meteor showers concentrated in the extreme. I'm thinking it's C. The interaction of the charged particles with the sun's magnetic and Earth's magnetic field. So the ionization levels necessary to create a visible aurora are far higher than what is necessary to create normal F-layer propagation. Charged particles will, even with enough energy to ionize the E layer usually create havoc with the upper ionosphere. As beautiful as auroras are to watch, they are not generally an indication of good radio conditions. The Earth's magnetic field tends to cause auroral activity to concentrate near the Earth's magnetic poles. Excuse me. But this is not always the case. Extreme solar activity can warp the magnetic field. Lines far south of their normal homes, causing auroras to be visible far south of the Arctic. And the answer is C, so I was correct there. Spent a couple years up in Alaska. I got to see it a few times firsthand right up there, so that was neat. And it says, a little tidbit of good knowledge. Solar flares and sunspots affect radio wave propagation. So, let's see here. What did we do? 2, 3, 4, 5, 6, 7, 10. Yeah, we went through 15 questions tonight on the skywaves and contesting, which is the second grouping of the questions. Let's see, looks like a few more pages. Probably the next session I do would finish up that section and possibly get into looks like the space comms and satellite stuff. So we will see where that goes from there. So part 6 we should finish up skywaves and contesting, and then move on into the next session. Maybe get a few out of there. So I'm definitely been picking up some stuff, and doing it this way is helping me kind of retain some of it. Well, there we go. Didn't want to click over for me. Well, I appreciate you joining me, and I look like we had a few others pop in and out there, but thanks a lot. I hope it was informative and a good session for everybody, and we'll go from there. And as always, get on the air. Thanks a lot.